So now on to some of the other V's. The next one is veracity, and this is about the truthfulness or correctness of the data. And this is down to the fact that the more you use data that others have collected, the data that's out there, the harder it is to be sure of where it came from and whether it's actually correct. There are things that we can use to help with this, and later in the course we'll be looking at things like metadata associated with data to make sure we understand what the data is about, so that we can check up on its veracity. But this is an issue that has to be dealt with. The next one is validity, and this is related to veracity, but it's slightly different. The data might be correct, but is it actually suitable to answer your question? So again, there are things that can help with this, and it really boils down to understanding as much about the data as possible when you're using it. So either having very well labeled data that's linked together so you can work out what it's actually about in more detail. And this also relates back to the idea of substantive expertise, having an expert in the subject that you're working on and the question that you're trying to answer, because this is very important to being able to make sure that the data that you have is actually suitable to answer your question. Of course, you can now do things in some cases the other way around. With large amounts of data, you can take the data as a starting point and see what questions it could answer. So this is a slightly different approach. It's more like the fourth paradigm approach in science. So you look at a large amount of data and see what questions you could answer with the data. It's often a harder thing to do rigorously, but there are techniques out there that allow this to be done. Another V is visualization. As I've mentioned already, I'm afraid we won't have time to go into this in detail on this course, but it's one aspect that becomes even harder when we're talking about big data. So at some point, humans have to consume data. This is about the final understanding stage, what you get out of this data. So either you do lots of algorithmic processing on it to reduce the big data into some more manageable data that you can, a number or a line on a graph that you can understand. But sometimes you also want to be able to just look at the whole mass of data that you start from and do some kind of exploratory data analysis and try to understand your data. And at this point, having new visualization techniques that can deal with large amounts of data and present them in ways that a human can understand become increasingly important. The next V is visibility, and this is about making sure that the data is visible to everyone who's meant to see it, but invisible to everyone who's not meant to see it. So this is really a question of authentication and authorization. And it also touches on the idea of who's meant to see it anyway, of course, and this is goes into some of the ethical questions that I mentioned that need to be addressed when we're considering data science. Maybe visibility wouldn't be the obvious word to use there, but it begins with V, so you can see why it's been chosen. The next V is variability. So if we look at pretty much all the above, they can all vary with time. And the bigger your data, the bigger the dimensions that we've been through before, the more scope you have for this to vary and change substantially, change in some real way with time. So you might have to process data in different ways at different times or use different computing resources. So one partial solution to this is the idea of cloud computing, computing on demand, the idea that instead of having a computer which is of the right size to work with the kind of problems that you deal with, it may be that you need different sizes of computers at different times. And so by using cloud computing, computing on demand, the elastic aspects of cloud computing, it means that you can make use of the resources efficiently and cost effectively in order to deal with different amounts of data at different times. So It's not a solution to all the variability aspects, of course, but it's one possible solution. So talking of one possible solution, this brings me on to my last couple of points. For some people, big data means Hadoop. And of course, I would argue that big data is not the same as Hadoop. Hadoop is just one solution to some of the problems of big data. It's an important solution, it's very powerful, it's very widely used for some classes of problem, but you can't solve all big data problems with Hadoop. Hadoop is an implementation of MapReduce, so it's a reusable parallelization strategy applicable to large data sets. We'll come on to it a little bit more in the latter part of this course. We'll go into MapReduce in a bit more detail, and we'll illustrate that with Hadoop because it's the most common MapReduce framework. And what about NoSQL? Again, this is another silver bullet that a lot of people now think can solve big data problems. Again, this is just one more solution to some of the problems. So NoSQL databases, again, we'll come on to this in a couple of weeks' time. But in summary, these NoSQL databases are databases with some constraints relaxed so that they can work more efficiently at scale. So they're new kinds of databases that basically throw away some of the features that you had with traditional relational databases in order that they can work more efficiently at scale. And the different kinds of NoSQL databases that you will come across often differ. Their main differences really are about what features of relational databases they throw away in order to get you your efficiency at scale. So in summary then, big data is about having to think differently about how you work with your data. It possibly means scaling out. By that I mean using more computers, whether that's in a data center, whether that's using some kind of cloud computing solution. And it's not just about scaling up. So there are some problems where you can just build a bigger computer, but there are limitations, particularly cost limitations, as to how big a single computer that you can build. So scaling up is often not the answer for these big data problems. It often means using new tools, some of which we're going to be able to talk about on this course. We won't go into a lot of detail on specific tools. Generally speaking, the tools are things that can change very frequently, and this is something that the best way to find out about tools is to try them out. But importantly about big data is that what we're trying to get at here is new insight, and this is what big data can potentially provide. So with this new insight you also get more value, and this is why we're working with big data in the first place. So it's a double-edged sword. You've got the problems of big data that we have to learn to work around, and there are the opportunities that big data bring, and these are what makes going through the difficulties of working with big data worthwhile.